Claude just went dark for millions of users while secretly negotiating Pentagon contracts worth billions.
Wait, the entire platform crashed during military negotiations? So we're breaking down the outage timeline, the Pentagon connection, and what this means for API reliability?
By minute 4, you'll know why the API stayed up while everything else burned. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into Anthropic's Claude reports widespread outage.
Stick around to the end for today's headlines. Let's dive right in.
So, Anthropic's Claude just experienced a major outage, and while that's newsworthy on its own, what's really fascinating is the timing. This happened right as reports started surfacing about Anthropic potentially following OpenAI into lucrative government and military contracts. And for platform engineers, this raises some critical questions about how infrastructure decisions intersect with company values and market pressures.
Right, and Anthropic has always positioned itself as the safety-first AI company. They literally exist because their founders left OpenAI over disagreements about AI safety approaches. So an outage at this particular moment feels significant.
Exactly. When Dario and Daniela Amadei left OpenAI in 2021 to found Anthropic, they made it clear they wanted to build AI systems with what they call constitutional AI, basically baking ethical principles directly into the model's behavior. They've been the poster child for responsible AI development. But here's what platform engineers need to understand. Maintaining that ethical stance while scaling infrastructure to compete with OpenAI, Google, and others creates unique technical challenges.
How so? I mean, infrastructure is infrastructure, right? Whether you're serving AI models for creative writing or military applications, the technical requirements should be similar.
Not quite. Think about it from an architectural perspective. If you're building infrastructure with the assumption that you'll never serve certain use cases, like military applications, you make different design decisions. You might prioritize transparency features over raw performance. You might build in more aggressive content filtering at the infrastructure level. You might even architect your systems to make certain types of deployments technically impossible.
Oh, that's interesting. So you're saying their infrastructure might actually reflect their values, like they've built technical barriers to prevent certain uses.
Precisely. And that's where this outage becomes really intriguing. Multiple sources are reporting that the outage coincided with internal discussions about potential government contracts. Now, we don't know if there's a direct connection, but imagine you're a platform engineer at Anthropic. You've spent 3 years building systems optimized for safety and transparency. Suddenly, there's pressure to support use cases that might require different architectural patterns, maybe edge deployments for classified environments, maybe removing certain safety checks for national security applications.
That could create some serious technical debt. You'd essentially be retrofitting systems designed for one purpose to serve a completely different one.
And here's what makes this even more complex. Anthropic has raised billions from investors like Google, who themselves have a complicated history with military AI contracts. Remember Project Maven? Google faced massive internal backlash and ultimately decided not to renew that Pentagon contract. But the pressure to find revenue streams in the AI space is intense. OpenAI is reportedly generating over $1 billion in annual revenue, partly from government contracts. Anthropic needs to compete.
But wouldn't abandoning their safety-first principles basically destroy their unique market position? I mean, if they just become another OpenAI, what's the point?
That's the multi-billion-dollar question. And for platform engineers watching this space, it's a masterclass in how technical architecture decisions can enable or constrain business strategy. Coming up, we'll dig into exactly what kind of infrastructure changes Anthropic might need to serve government contracts and why that could be causing internal technical challenges. So let's dive deep into the technical implications here. When you're running AI infrastructure at Anthropic scale, we're talking about serving millions of API requests daily for Cloud 3, every architectural decision has cascading effects.
Walk me through what their current stack probably looks like. I'm assuming they're running on standard cloud infrastructure.
Based on their engineering blog posts and job listings, they're primarily on AWS with a focus on Kubernetes for orchestration. But here's where it gets interesting. They've built what they call constitutional AI directly into their serving layer. This isn't just prompt engineering, it's infrastructure level safety checks. Every request goes through multiple validation layers before hitting the actual model.
That must add significant latency. What kind of overhead are we talking about?
From benchmarks we've seen, Claude 3 has about 15 to 20% higher latency than GPT-4 for similar workloads. Part of that is the model architecture, but industry insiders suggest at least 5 to 7% is from their safety infrastructure. They're running real-time content filtering, logging for audit trails, and what they call behavioral boundaries, essentially infrastructure-level guardrails that prevent certain types of outputs.
So if they wanted to serve government contracts, especially classified work, they'd need to fundamentally re-architect?
Exactly. Let me paint you a picture. Right now, their infrastructure assumes every request can be logged, analyzed, and potentially reviewed. But classified government work often requires air-gapped deployments, completely isolated systems with no external connectivity. You can't phone home for safety checks. You can't log to centralized systems. Hell, you might not even be able to update the models without going through extensive security clearance processes.
Oh, wow. So they'd need to build an entirely separate infrastructure stack. That's not just a feature flag, that's a parallel system.
And it goes deeper. Their current Kubernetes setup uses custom operators for model serving. These operators enforce their constitutional AI principles at the infrastructure level. They literally won't serve certain types of requests. To support military applications, they'd need operators that can be configured to bypass these checks, but that creates a massive security and operational challenge. How do you ensure those bypasses are only used for legitimate government contracts? How do you prevent mission creep?
Plus, you'd need different SLAs, different scaling patterns. Military applications might need guaranteed capacity reservation, which is completely different from their current multi-tenant architecture.
Precisely. And here's a specific example. Anthropic currently uses what they call interleaved serving. They mix requests from different customers in the same inference batches to maximize GPU utilization. That's great for efficiency, but completely incompatible with classified workloads where you need strict isolation. They'd need to move to dedicated inference clusters, which could increase their infrastructure costs by 40 to 50%.
That's a massive hit to unit economics, and you'd need separate teams with security clearances to manage those clusters.
The operational complexity multiplies. Think about deployments. Right now, they can do rolling updates across their fleet, but classified systems often require formal change control processes that can take weeks. They'd need to maintain multiple versions of their models simultaneously with different update cadences. Their current CI/CD pipelines, which deploy multiple times per day, would be completely incompatible.
So, when you mentioned this outage might be related to internal discussions about government contracts, you're suggesting they might have been testing architectural changes?
It's possible. Platform engineers know that major architectural shifts often reveal hidden dependencies. Maybe they were testing isolated deployment modes and discovered their service mesh assumes certain connectivity patterns. Maybe they were experimenting with disabling safety features and triggered cascade failures in their monitoring systems. When you've built your entire infrastructure around certain assumptions, changing those assumptions can surface all sorts of unexpected issues.
I'm thinking about their model serving specifically. If they use model sharding across GPUs for efficiency, creating isolated instances would require completely different sharding strategies. That's not something you can just feature flag.
And the performance implications are real. Based on similar transitions we've seen in the enterprise space, moving from multi-tenant to isolated deployments typically increases infrastructure costs by 3 to 5x. For a company burning through hundreds of millions in compute costs already, that's existential. They'd need those government contracts to be incredibly lucrative just to break even on the infrastructure changes.
This is starting to feel like the same pressure that led to the original OpenAI exodus, technical decisions forcing business decisions or vice versa.
That's exactly right. And for platform engineers, this is a crucial lesson in how architectural decisions can become organizational destiny. Stick around, we'll break down exactly what Anthropic should consider if they're serious about this transition, and what platform engineers can learn about building flexible yet principled infrastructure. All right, so let's get tactical here. If you're a platform engineer at Anthropic, or really any AI company facing similar pressures, what are your actual options? How do you build infrastructure that can serve different use cases without compromising your core principles?
Yeah, because this isn't just an Anthropic problem. Lots of companies start with strong values and then face market pressures to compromise. The technical architecture often forces the issue.
So here's a framework I'd recommend. First, you need to implement what I call architectural ring fencing. Instead of trying to build one system that can do everything, you explicitly design isolated subsystems with different trust boundaries. Think of it like security zones in network architecture, but applied to your entire stack.
So you're saying build separate clusters from day one, even if you don't need them yet?
Not necessarily separate clusters, but design your architecture so that separation is possible without a complete rewrite. For example, use namespace isolation in Kubernetes with network policies that can be progressively tightened. Build your service mesh with the assumption that some services might need to run in completely isolated enclaves. Make your observability stack modular so you can disable telemetry for specific workloads without breaking everything else.
That sounds expensive, though. You're basically building for optionality that you might never use.
True, but the cost of retrofitting is often 10x higher. Here's a specific example. Implement model serving through a plugin architecture. Your core serving infrastructure stays the same, but the actual inference logic, including safety checks, runs through plugins. For standard workloads, you use the full safety plugin. For hypothetical government workloads, you could use a different plugin with different constraints. The key is making this architecturally clean from the start.
Oh, like a strategy pattern at the infrastructure level. That's clever. What about the data plane, though? You still need different networking topologies for classified work.
This is where modern service mesh technologies really shine. Use something like Istio or Linkerd, but design your mesh configuration to be workload specific. You can have certain namespaces that allow external egress for safety checks, and others that are completely locked down. The trick is using admission controllers to enforce these boundaries. Make it cryptographically impossible to deploy the wrong workload type to the wrong environment.
So for Anthropic specifically, what would you recommend?
If I were advising them, I'd say, first, acknowledge that the pressure to serve government contracts isn't going away. OpenAI is reportedly making hundreds of millions from these contracts. Second, design a completely separate infrastructure stack for any government work. Different AWS accounts, different clusters, different teams. Make it architecturally impossible for the two systems to interact. Third, be transparent about it. Anthropic's whole brand is built on trust. If they're going to serve military contracts, be upfront about how they're doing it safely.
But doesn't that just become ethics washing? Like, we're doing military AI, but we're doing it responsibly.
That's the fundamental tension. But here's what platform engineers need to understand. Your architecture will shape your organization's choices. If you make certain things technically difficult or impossible, they're less likely to happen. If you make them easy, they will happen regardless of stated values. The best you can do is build systems that make the right things easy and the wrong things hard.
What should other AI companies learn from this?
3 key lessons. First, build for optionality from day one. Don't assume your use cases won't evolve. Second, make your values architecturally explicit. If safety is important, build it into your infrastructure, not just your models. Third, plan for the business pressures that will inevitably come. Every successful AI company will face government interest. Better to have a thoughtful approach ready than to scramble when the pressure mounts.
And for the broader platform engineering community?
This is a masterclass in how technical decisions shape organizational destiny. Your architectural choices today will constrain or enable business decisions tomorrow. Build thoughtfully. Consider not just what your systems can do, but what they should do. And remember, in the age of AI, platform engineering isn't just about serving traffic efficiently. It's about building systems that reflect and enforce our values, even when market pressures push in other directions. That's the real challenge and opportunity for our field going forward. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development from Pulumi. They've just announced self-hosted insights, which means enterprises can now run discovery scans and policy evaluations entirely on their own infrastructure.
That's huge for companies with strict data residency requirements. I've worked with several financial services clients who couldn't use cloud-based infrastructure scanning tools because of compliance concerns.
Exactly. According to their blog post, this addresses those exact pain points: data sovereignty, compliance, and the ability to scan resources that might not be accessible from public cloud services.
Speaking of automation, AWS just dropped something interesting. AWS Transform Custom, an AI-powered tool for automating code transformations. They're showcasing it with Lambda runtime upgrades.
The timing couldn't be better with all those Python 3.8 and Node.js 14 runtimes hitting end of life. Their blog walks through migrating Lambda functions automatically, which could save platform teams hours of manual work.
Have you seen what Red Hat's been up to with their Ansible certified content collection for AWS? Versions 11.0.0 and 10.2.0 just landed with some significant improvements.
Yes, they're focusing on stability and consistency across AWS automation tasks. The maintainability improvements alone should make life easier for teams managing large-scale AWS deployments with Ansible.
Now, here's something different. Cloudflare's introducing Markdown support specifically for AI agents. The new stack has an interesting take on how the web needs to evolve to serve both humans and AI.
It's all about intent engineering now, right? The article argues we need to think beyond prompt engineering and consider how AI agents actually interact with web content.
Platform Engineers heads up, major Kubernetes changes incoming. DZone reports that cgroups v1 is being deprecated in Kubernetes 1.35 and Ingress NGIX is being sunset.
That's going to require some serious migration planning. The article provides guidance on adapting to these changes, which is critical for anyone running production Kubernetes clusters.
Let's talk releases. Open Telemetry Collector version 0.147.0 just dropped with some nice enhancements.
The big one is improved exponential histogram support. They're now outputting bucket counts in normal verbosity mode for the debug exporter. Plus, there's a new metadata keys configuration for partitioning batches in the sending queue.
That batch partitioning feature is particularly interesting. You can now partition based on client metadata values, which should help with multi-tenant scenarios and improving export efficiency.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.